Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 4B. Myself, Ashutosh Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Amit Thakur. Dr. Amit Thakur is working as a professor and head in the Department of Computer Science and Engineering in the Faculty of Engineering and Technology, Chausat University, Changa, Gujarat, India. He has published 3 books in the area of data mining. He has also served as a member of the technical committee at various national and international conferences and journals. His current research interests include machine learning, deep learning, and embedded deep learning. I would now like to invite Dr. Amit Thakur to share a few words of encouragement with our attendees as we begin this session.
Thanks, Atudev, for the introduction and the welcome remarks. So, yes, I also welcome all the participants across different countries from the globe. I expect that you all focus during the session regarding the novelty of your research work. As we are limited time for the presentations, skip the basic concepts and then focus more on the novel work that you carried out with experimental results if you have any. So wish you all the best, and I think we will begin with the first presentation.
Thank you for your kind words, sir. Now, without further ado, let's begin the session for the day. First off, I would like to invite Sir Uttam Patole for presenting his paper titled An Integration Machine Learning Model for Automated Drip Irrigation and Crop Disease Management Using Robotics. Sir, do we have you here with us?
Yes, sir.
Okay. I will stop presenting. You can start presenting your screen.
Hello, good morning, everyone. I am Abhishek Deshmukh, the co-author of our research work, and I am here to present the paper title An Integrated Machine Learning Model for Automated Drip Irrigation and Crop Disease Management Using Robotics. I am presenting this work on behalf of Mr. Uttam Patole, who is unable to attend due to travel communities. Can I share my screen, sir?
Yes, you may present your screens.
Now, sir, as agriculture faces the challenges like water waste, disease spread, and insufficient crop planning. So, our proposed solution use machine learning to classify the soil type and recommend the suitable crop and manage the irrigation and disease using robotics. The model combines the satellite imagery and ground sensors and decision making algorithm, encouraging the data driven sustainable for farming, sir. Next. uh, so the what problems faced by farmers, let's discuss. The farmers often rely on an institution for the farming, but this leads in insufficient irrigation or excess use of pesticides or the lose in productivity of crops. So the traditional system handles this as a soil classification, then recommend the crops. These things not integrated in the traditional system. So this process next Sir, we have studied the some cases. The first studied case by Johnson and Maternis, published in 2021. Uh, they proposed the vector machine-based approach for detecting the plant disease in smart farming. Their method applied the imaginary image classification technique to identify the diseased plant. However, the limitations was that it focused only on the disease detection and didn't incorporate the real-time irrigation or robotic automation. The second study by Ahmed Mohammed and Ali in 2022, they focus on predicting crop yields using deep learning and remote sensing data. Uh, they they deploy they developed the smart irrigation system that adjusts based on the weather and soil condition. But again, the limitation was that it only so it only addresses the irrigation without considering the disease detection. That is the drawback. Then at lastly, the by Kumar and Singh in 2023, they propose using the random forest algorithm for integrated system that include irrigation and pest control. While they did manage to integrate both functions, their approach lack of multi-sources data integration, such as real-time weather input or sensor feedback from the field. That's about the literature review. Now next, our proposed method. Our system consists of an seven modules. The first is data collection. Through the sensors and the satellites, the data is collected. Then the processing to clean and the normalize and analyze the data is done in this data processing. Then machine learning model, uh, in which we have used the forest random forest and gradient boosting algorithm. Then soil classification model, which detects the soil type. Then fifth is a crop recommendation model. It suggests the crop, means to which crop we have to cultivate. Then the output reference, in which the user-friendly interface is designed for the farmer to view their results and recommendations easily. Then the crop disease detection using robotics and automation, means the disease are detected by robotics and automation. Thank you. Next, the data description. We have used data from IoT, soil sensors, multispectral and biochemical sensor, and historical weather records. The In processing, it includes the noise removal, then feature scaling, and interpolation of missing values to improve the model accuracy. In which noise removal, uh, to handling the missing values, means in some data some values may be null or not applicable. Then we have to handle that missing values to get the accurate result. Then next, the result. The system achieves the 35% reduction in water usage through the smart irrigation, then the 45% reduction of in a disease spread with early detection, then 75% reduction in manual labor using robotics, uh, which helps in the
This is a
productivity.
gentle reminder.
Yes, sir.
This is a gentle reminder that 9 minutes have been completed.
Okay, sir. Now only. At the conclusion, we presented a smart precision agriculture system combining with ML and robotics. It adapts the live data and improve the farming efficiency. The challenges remain such as sensor cost and the scalability, but it's a strong foundation for future smart agriculture solutions, sir. Then in here there are some future scopes also. The real time weather integration, uh, advanced robotics and drones, affordable IoT sensors.
So
uh,
you have exceeded the 10-minute time limit. Kindly conclude the presentation.
okay, here's are some references, and then thank you, it's over, sir, from my side.
Thank you for your presentation, sir. Are there any
Yes.
questions?
Can you tell me how you have integrated robotics with machine learning algorithm?
Sir, machine learning we can integrate by collecting the data like the images of means diseased crop, and then checked for further disease. The data such as images or like images only, sir.
Have you worked on any real-time analysis system?
Actually, sir, we have only proposed this, but we have not implemented the hardware till now.
Okay, thank you.
Moving on to the next presentation, I would now like to call upon Ma'am Shruti to present her paper on the title Deep Learning Neural Networks for Healthcare Applications. Do we have you here with us, ma'am?
Yes, sir. I'm that, sir.
Okay, I will stop presenting.
Okay. Sir. Good morning, sir. This is T. Shruti. And now I'm going to present my. Can I share my PPT, sir?
Yes, ma'am.
Okay. My title is about the deep learning neural network for an healthcare application, sir. I'm T. Shruti. My guide name is Shashikala. I'm pursuing my PhD in SR University, Warangal, Telangana. Okay, sir. When coming to my abstract, in nowadays, if I have taken the example of any cancer, means the cancer, how it was affecting to these people, means so in order to go while testing, means we have to go for the MRI scan and genetical problems if want to identify it perfectly how it coming to the humans, means in the 2 or 3 ways we have it. So in order to analyze all these things, it is only the single proposal I want to introduce here. I want to propose my in my PhD proposal that multiple purposes by taking the MRI scan and heterogeneous, that is nothing but first a genetical problem I can identify, and then I want to go for the heterogeneous, and the problems regarding the heterogeneous is, suppose if I have taken a few people when they are staying in particular villages, they have only the kidney problem. Why they have only kidney the problem? We have to analyze it due to the water, we can say due to it water. So in this way we have to identify it. But in the multi-purpose, when coming to the multi-purpose, as when coming to the my proposal, I am using here the keywords are deep learning architecture and healthcare medical data and the pattern recognition. So when coming to the introduction, I want to analyze the problems of an breast cancer and eye and and one more is there, but here I have only introduced like in a breast cancer how it was affecting the people, how the analyzing by the like doctors or like a MRI scan by taking the MRI scan and it is. So when coming to the this architecture, the input layer is there and the output layer is there. Here the hidden layers is that there is a many combinations of any hidden layers are there. It is one related to the all the patterns in a hidden layer. So how why I'm showing this one means it can be identified when the minute like in a whether the cancer is very small or in a very minute is that we can identify it easily. So next pattern. So well by using the deep learning we have an algorithm, but I did not went for the algorithm because my research work I have done up to this only the deep learning by taking the deep learning architecture. So the hidden input layer is there and the output layer is there. Here we have many layers in middle. So each and every layer when you were seeing like in a breast cancer like in a MRI scan, it is only the doctors can know which has to be identified where you have to get the problem. So in this you have many layers. Each and every layer is connected with an input layer and the output layer. So like an I can say a ductile. Ductile means a very small, minute of an like very small, minute problems we can recognize by multiple layers. Okay, so this is mainly found in an women's. So when the ductile means it can be found when mostly the age of an 42 around the 60 age, because the male glands will form according to the and it will say as a ductal. So when coming to this picture in the first picture I can see there are the many ductals. After identifying the multi-proposals, they have the mind, they have the exact reason where you have find the like a problem. Okay, when coming to the third picture, you will exactly find where it is. Exactly the picture has identified where the problem and where the picture has to be identified and where the problem has exactly find it. So that in these cases, they are doctors can easily find out these proposals. Okay, conclusion. I want to extend my proposal to the a further extension like an algorithms, and I want to add the proposals and the architectures of this one. And this is my first paper on this proposal on the healthcare center. Thank you, sir.
Thank you for your presentation, ma'am. Are there any questions?
How you have planned to use multi-model data for this problem?
Yes, sir. Multiple models, sir.
Which different data modality will be going to consider?
Yes, sir. But nowadays only the single model is there, sir. But want to identify by taking the multi-model things.
Which are those multi-model modalities you are going to consider?
A single model means only will go by the MRI scan. In multimodal MRI scan, like in a heterogeneous, like in a genetical problems, we can identify it by database, whatever the patient has to up to now the lifestyle of a patient. By all these things, I can get the exact reason how it was affected the patient.
Okay, thank you.
Thank you, sir.
Now moving on to the next presenter. I would now like to call upon Ma'am Ria Jawali to present her paper on the title Efficient Real-Time Dynamic Network Slicing for 5G to Meet Diverse QoS Demands. Do we have you here with us, ma'am?
Good morning, sir. Can you hear me?
Yes, you're audible, ma'am.
So shall I present?
Yes, ma'am. Just a second. You may present now.
Okay. Morning, everyone. I'm Riya Javli, and I'm really excited to present our research on dynamic network slicing in 5G, done in collaboration with my co-authors from Kerala Technological University. Our work focuses on how we can make 5G networks more efficient and adaptable in real time to meet diverse QoS demands. Here's a quick overview of what I'll be covering today. We'll start with an introduction to what network slicing is and why it matters in 5G. Then we'll go over some related work, our project objectives, and how we built a simulation model. After that, I'll show you some results and how a dynamic model compares with a traditional static slicing model. Finally, we'll wrap up with some conclusions and future possibilities. So 5G isn't just about faster internet, it's about smarter, more adaptable networks. The biggest features is network slicing in 5G. It's basically creating separate visual networks slices on top of the same physical infrastructure. For example, one slice can be designed for high-speed video streaming or gaming, another for ultra reliable applications like autonomous vehicles or remote surgery, and yet another for connecting thousands of IoT devices in a smart city. Each device has its own performance parameters like the bandwidth, latency, and reliability. And that's what makes 5G so powerful. It offers personalized connectivity without compromising on the efficiency. A lot of work has been done on this, especially around static slicing, where the resources are pre-allocated, the slices. Some researchers have used machine learning to predict traffic and adjust bandwidth. Others have proposed resource-aware framework for better performance. But one common issue we noticed is that many of these models don't really simulate real-world user activity, real-world user behavior, especially in a multi-base station setup. There's the gap that we try to fill. Our goal was to build a dynamic, realistic simulation model that reflects how users actually use the network throughout the day. The objective of the project. So what we are trying to achieve is, first we wanted to develop a real-time dynamic resource allocation mechanism that adjusts based on user demand and the service requirements. Second, we aim to simulate realistic user behavior, things like peak hour usage, varying demand for different slices like EMBB, URLLC, MMTC, and voice. Finally, we want to evaluate how well each slice performs using matrices like bandwidth usage, coverage ratio, and prioritization. Now, let me walk you through our overall approach. We started by configuring our simulation environment. This includes fixed base stations with defined capacity and coverage areas. We then defined slices like EMBB, URLC, voice, and MMTC, with its own bandwidth and QoS requirements. We simulated user activity hourly across a 24-hour cycle. Demand for each cycle changes over time, over the day, just like in real life. Then comes the core, which is the dynamic bandwidth allocation. Based on demand and QoS priority, the bandwidth is assigned slice by slice. And if there's extra capacity, it gets fairly distributed across the remaining slices. All this data is logged for visualization and for analysis. Here's a closer look at how the system is structured. Each base station handles user connections and serves the slices according to their capacity. Slice attributes like delay, tolerance, and priority are randomly generated within realistic bounds to simulate the natural variation. Highest ultra low latency, so it gets the highest priority. Voice or MMTC slices may tolerate some delay, So they get bandwidth after the critical slices are satisfied. And because user demand is randomized hourly, so we observe how the system adapts dynamically over the time. So coming to our results, this graph shows the user activity per slice at 8 base stations and the bandwidth allocated to each slice. So we have over 8 base stations and 4 slices, and how the bandwidth is allocated to each slice. This graph shows user activity throughout the day at different base stations. Here I've taken an example of 2 base stations. You can see that some stations experience more voice or MMTC traffic in the morning, while others have UMBB demand peaking in the evening. These kind of shifts are important for testing how well the dynamic slicing holds in varied scenarios. Each slice behaves differently depending on location and time. Our model effectively handles these shifts by redistributing the bandwidth based on the latest demand and priority, helping the network operate smoothly under changing loads. When we analyze performance, a few things stood out. First, bandwidth utilization went up significantly, nearly 30% higher than static methods. Second, we managed to maintain a zero block ratio, meaning that no user was denied access to the network. And finally, high priority slices like the URLLC always received the bandwidth they needed, ensuring critical services remained unaffected. How does a model stack up against the traditional static slicing is that it provides stable performance. That static slicing provides stable performance, but it can't really adapt to fluctuating traffic. You might end up wasting resources when the demand is low or causing delays when the demand spikes. But in case of dynamic slicing, on the other hand, is a bit variable. But that's a good thing. It reacts to changes, it adjusts the bandwidth where needed. As a result, it can support more users and offer better overall efficiency. Shown comparison for bandwidth usage, client ratios, and slice efficiency, and across the board, the dynamic slicing model comes out ahead with about latency reduced by 20%, resource utilization improved by 30%. So to wrap up, our dynamic slicing model not only handles real-time traffic efficiency, but it also improves QoS, reduces the latency, and utilizes bandwidth more effectively. It reflects the real-world network conditions much better than the traditional static slicing models. Includes integrating the ML for predictive slicing and using real-world 5G traffic traces to enhance the simulation accuracy. Some of the key references we used. These include recent IEEE publications on dynamic resource allocation, ML-based spectrum prediction, and simulator comparisons like the Simul5G. Thank you, sir.
Thank you for your presentation, ma'am. Are there any questions?
Can you tell me how your algorithm supports adaptive slicing, or how do we measure the performance of adaptability under different QoS parameters for different use cases?
Yes, sir. So our model, we have used a dynamic slicing model, which means after all the slices are allocated, each slice is allocated a different priority, and the slice with the highest priority will receive the bandwidth first, and next all the lower priority models. And if the bandwidth is remaining, it will be fairly distributed among all the slices. So in real life scenarios, this is how the network, it is a reflection of how the real world scenarios. So in fluctuating traffic or at peak demands, the bandwidth allocation is important. So that is what we're trying to build.
So apart from bandwidth allocation, is there any other measures available by which we can ensure adaptability of the model?
Yes, sir, as I've said, the client connection ratio, the coverage ratio, etc. These are all the parameters that we have used to analyze our model.
Okay, good. Thank you.
Since there's no response, we'll be moving forward. I would now like to call upon Sir Bipin Sai Bhaskar to present his paper on the title Enhancing Tuberculosis Detection with HPC-driven GAN-CNN integration and model parallelism for synthetic image generation. Do we have you here with us, sir?
Yeah, hello everyone. Hello everyone. Myself Vipin Sai Bhaskar from SRM Institute of Science and Technology.
Myself, Hemendra from SR Ministry of Science and Technology.
Our project title is Enhancing Tuberculosis Detection by with HPC driven GAN. Uh, one second, sir. There is a network issue. Hemendra, please continue this. Hello.
And enhancing tuberculosis detection with HPC-driven GAN, CNN integration, and model parallelism for synthetic image generation. Our abstract. In our project, we are using novel machine learning framework to enhance tuberculosis to find cure for tuberculosis using machine learning. Here we are using generative adversarial networks (GAN), which produce synthetic images, and HPC to accelerate the training for CNN models. Okay. As we see, tuberculosis remains a very serious issue, particularly in remote areas. If it increase if the patient is not cured in early stages, it becomes very fatal disease. So you have to cure it in early stages. For that, we are using multiple technologies using machine learning to find the cure for tuberculosis. So our justification for approach, how are we going to do? In our situation, there is not enough data. So we are using synthetic generating. We are generating synthetic images using GAN. In our situation, we are using AC GAN. As we see, using GAN relatively slows your system because it's very heavy computing process. So we are using HPC, high performance computing, to accelerate the speed of training. These are some related works. In related works, we have noticed that nobody has used synthetic images or tried to boost up the speed using HPC. So I combine these both scenarios in our project.
Yeah, if you see in this, there is an imbalanced data and slow training and scalability in this. After we are going to objectives. In these objectives, our key goal is to improve data size and balancing using GAN and train models faster and efficient by using HPC. And also we built an accurate and reliable systems to detect TB from just X-rays. This helps make diagnosis quicker and more accessible. And in proposed system, TB dataset have very few positive cases. We use GAN to generate synthesis TB X-ray images and balance the data. The training is done by using 4 to 8 GPU nodes in parallel and making it faster. While seeing the CNN model, this diagram shows how model parallelism works. Like we split the model into parts. For example, one GPU nodes runs part A and the next runs part B, and so on. Like this, it will train very large models, and that would fit in one's computer's memory. After we seeing this data flow diagram, real and synthesis images are used. Like the discriminator checks if images are real or fake and gives feedback to the CNN, which classifies whether the person has TB or not. Um, like by seeing this architecture diagram, this is the overall architecture. You can see how the GAN, CNN, and HPC together works. The system is designed to handle large amount of data and gives faster and accurate predictions. Mm. After seeing these modules in module one, we are getting that data input and preparation, and we realize normalization and clean them Then we apply data augmentation like rotation and flipping and cropping. This gives us more useful data to train on. These are the synthesis images generated by using GAN. Here we have used HPC for speed up the process when we are using synthesis images. These are the output getting from by using CNN. In this model 4, we have trained the CNN by using the combined data set, and we evaluated it by using accuracy, precision recall, and ROC curves. We also have hyper parameter turning to improve performance. These are the output we have get. We have get an accuracy 0.94. Here we can see the training and validation loss curves, both are close to zero. Like this shows that GAN generated data helps our model learn better without overfitting. And this is the conclusion. Our project uses GAN to create more images and CNN to classify them and HPC to train quickly. This system gives fast and accurate and reliable TB detection, especially where resources are limited. Like the systems can be extended to detect other diseases like pneumonia, lung cancer, and COVID-19. We can also use advanced GAN models like style GAN or diffusion models to generate even better images in future. Thank you.
Thank you for your presentation, sir. Do we have any questions?
Is there any other way to handle the class imbalance problem apart from augmentation? Any other technique do you know?
We use CNN for classification. And to speed up the process, we have used HPC. And with the scarcity of data set, we use GAN for produce synthesized images.
Okay, have you tried that your result with original data and result with synthesis data, and is there any difference in the results generated?
Sir, yeah, there is a result. We have implemented the code by using synthesis images. Is there time to show that code?
Okay, thank you.
Thank you. We'll be moving on to the next presenter. Now, I would like to call upon Sir Shankar Lingam to present his paper on the title ICT Policy and E-Governance, Navigating Intergovernmental Issues in the Digital Era. So, do we have you here with us? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward to the next presenter. Now, I would like to call upon Ma'am Gayatri Kishore to present her paper on the title Implementation of Predicting Space Weather Impacts Using Machine Learning Techniques for Aviation and Telecommunication. Do we have you here with us, ma'am?
Yeah, hi, I'm there.
Okay.
All right. So the name of our project is Predicting Space Weather Impacts Using Machine Learning Techniques for Aviation and Telecommunication Industries. Basically, this project focuses on the space weather impacts and the factors that affect the space weather. We focus majorly on the six factors, namely solar flares, solar energy particles, CMEs, IMFs, auroral disturbances, and ionospheric disturbances. So basically, the main motto of this project is to make a user-friendly interface specifically for aviation and telecommunication industries. The authors include Gargi Ragnikar, myself, my teammate Adarsh Nikam, and my teammate Manisha Mane. Introduction to space weather impacts. As I've mentioned, these are the six factors that we'll majorly be considering, starting with solar flares, which are basically sudden bursts of energy from the sun's surface that can release radiation and can reach Earth in minutes. Along with coronal mass ejections, which are basically giant clouds of magnetized plasma that erupt from the sun's corona, and they take several days to reach the Earth's surface. Magnetic storms are not exactly a part of the factors affecting around the space. These are more of the factors that are present due to the Earth's magnetic field, which is caused by the CMEs. following up with ionospheric disturbances, which are basically short-term variations from the normal state of the ionosphere that causes solar activities and earthquakes. Moving forward with interplanetary magnetic fields, that is IMF, which is basically the magnetic field carried by the solar wind as it flows outward from the sun. Then we have solar energy particles, which are high energy particles, primarily protons and electrons accelerated from solar eruptions. And finally, we have auroral data, which is caused by interactions between solar wind particles and Earth's magnetosphere. Following up with the literature review that we did before our project, basically, before there was any forecasting of the the space weather, we had incidents that disrupted the satellite communications as well as caused radio blackouts. One of these events include one of the major solar flare incident that happened in 1972, which leaded to a minefield near Vietnam, and it happened during the era of the war. And one of the major recent um, breakouts that happened because there was no solar weather forecasting happened in January 2023, which caused a GPS disruption. These also affected the airlines, as you can see in 1989, where airlines faced challenges in polar regions due to HF radio blackouts. And also airlines rerouted flights to avoid polar regions, which happened in 2003. So these are the major events that happened because there was no forecasting done for the solar weather. Our motivation behind this is mainly for the aviation users, as I've mentioned in the research background, that the airplanes had to reroute and there were radio blackouts, there were communication blackouts between the airplane, between the airlines, is one of the major reasons why we have made this project. One more reason is for the satellite operators, data on radiation levels, geomagnetic storms, and their potential impact that can happen on satellite operations, and also power grid operators, which again focuses more on the geomagnetic storms that is caused by the CMEs. Uh, our major objective of the dashboard is to enhance the situational awareness, basically providing more real-time insights into space weather and their potential impacts that can occur, along with predictive capabilities. As we have used machine learning models and deep learning models in this project, their predictive capabilities have a higher accuracy. And one more is the risk mitigation, which is basically decision making. Basically the alerts that are going to go to the of aviation operators and the telecommunication operators, we're going to make their predictive capabilities very accurate and very apt, and also along with that, make it a little more user friendly. Problem statement, as I've mentioned, our major two focus is the aviation and the telecommunication industries. One of the major disruptions that happen are radio blackouts. Basically, solar flares can interrupt radio communications, disrupting the air traffic control, aviation systems, and the emergency systems. Along with satellite mitigation, like geostorms can damage satellites disruptions and cause, and it can affect the navigation and the weather forecasting services. Now my teammate will explain the dashboard architecture.
So coming to the dashboard architecture, we have the front end, which is built in Next.js for an interactive and responsive user interface, while the visualizations for this is done using Unreal Engine, which is a 3D visualization a game engine for visualizing the auroral data, solar wind, and other space phenomena. Coming to the backend for data processing, we basically use the NASA's and NOAA, private US companies data, so that we can train our machine learning models, and the predictive outcome analytics and real-time visual data, including solar flare intensity, is basically given over there. For the database, we have basically used Microsoft Azure, which is a cloud-based storage option, and the Azure Blob Storage enables efficient handling of large data sets such as satellite imagery and time series data. So machine learning and deep learning algorithms that we have basically used are starting from the convolutional neural networks, or CNNs. These are basically deployed for image-based prediction, particularly for identifying and classifying imagery data. By analyzing satellite images, the CNN model will detect early indicators of solar flares based on the spatial patterns, aiding potential disruptions in communication and satellite operations. Then we have the RNNs and LSTM network applications, basically used for a sequential analysis of space weather data. These models are well suited for predicting solar, wind variations, geomagnetic storms, by learning their long-term dependencies in the data. So this is what we have basically used. Then we have the random forest for CME prediction. So random forest models augmented with a drag-based physics model will basically predict this solar mass ejections by integrating solar wind conditions and CME velocity data. This hybrid approach enables prediction more accurate. Then we have the SVMs for solar flare classification applications. SVMs will be used for binary or multi-class classification for solar X-ray flux levels. These models are particularly effective for smaller data sets where precise classification is crucial. Lastly, we have the gradient boost algorithms, which will predict the severity of geomagnetic storms, integrating features such as solar wind speed, density, and magnetic field strength. So this is what the architecture diagram basically looks like. A user logins to the front end, which is connected to the Unreal Engine, which basically visualizes your solar X-ray flux, solar X-ray wind, ionospheric disturbances, solar energy particles, interplanetary magnetic fields, and auroral data. So these are the model evaluation results which we basically got while predicting solar wind. These are actually predicted and tested against real-time data. So you can see the blue lines in the graph are basically the actual ones and the green ones are the predicted ones. Same for the SEPs or solar electron particles. This is what we have done is taken historical data and made a one-day forecast for it. As you can see, the blue line is the historical data, while the red dotted line is the predicted one. You can see it rises after certain days because it happens that the solar electron particles may increase.
This is a gentle
And
reminder that 9 minutes have been completed.
yeah, thank you. And then coming to the conclusion. So this is one of the visualizations which we have made using the Unreal Engine for the auroral data. And this is basically the visualization which we see. So this is completely made on Unreal Engine.
So you have exceeded the 10-minute time limit. Kindly conclude the presentation.
Okay.
All right. Thank you so much for listening. And we're done with our presentation.
Thank you for your presentation, ma'am. Are there any questions?
Have you evaluated the performance of your machine learning algorithm?
Sorry, sir, can you repeat that? I couldn't understand.
How you have evaluated the performance of your machine learning algorithm?
Yes, we have evaluated our performance. It comes up to 86% accurate.
You only use accuracy as a measure?
Yeah. Accuracy, MSE, and RMSE.
Okay. Thank you.
Okay.
Moving on to the next presenter. I would now like to call upon Ma'am Surya K to present her paper on the title Representation of Sensitive Issues in Media Using Generative AI. Do we have you here with us, ma'am?
Hello.
Yes, ma'am, you're audible.
Yeah. Hello, I'm Dr. Surya K. I'm working in Shivnadar University, Chennai. Shall I begin my presentation, sir?
Yes, ma'am.
Hello. Hello, I'm Dr. Surya K. I'm working as assistant professor in Shivnadar University, Chennai. And sir, am I audible?
Yes, ma'am,
Hello?
you're audible. Yes, ma'am.
Okay, thank you. I'm working as assistant professor in Shivnadar University, Chennai, and the title of my presentation is Representation of Sensitive Issues in Media Using Generative AI. And this is my presentation outline. I'll cover the motivation of my research work, followed by introduction to my research, then related works, proposed method, finally results and conclusion. So the general motivation behind my research work was that I was just inspired by a news article which came in 2023, I guess. Like a brother just stabbed his younger sister when she was just bleeding due to menstrual cycle. And since he doesn't know that ladies have certain issues, though he was married, he was unaware of his wife menstruating, or I do not know. So that was the motivation. So when I came across this generative AI, which can generate meaningful images, concepts, videos, or any new content in a conceptual way. So I just thought I had an motivation in my mind to solve such issues which shouldn't happen in future by using the latest technology, that is generative AI. So I thought of just so once I completed my PhD, I joined here as assistant professor. I just started to explore this generative AI since it was new. This ChatGPT, DeepSeek, everything was evolving at that time. I started to do my research work on this particular field, that is generative AI, and I try to solve some societal problems using the latest technology available. And so that was a deep motivation behind my research, and of course, this research paper as well. So introduction is that that is whenever we do research, according to my perspective, it should be in a way that it has some societal benefits. It should benefit the human being so that we improve our standard of living and avoid such unnecessary deaths or whatever it might be. So by using this particular technology in our project, we have just considered the problem called images. That is, we will be generating conceptual images for some of the sensitive issues that must be addressed to the society. The main agenda here is that we are just trying to explain the sensitive issues probably only through images. That is, even though if a person is uneducated, he will be able to understand the concept by looking at the images. That is, the images are represented in a conceptual way. So what we have used, coming to a technical background, what we have used is that we have used generative AI, that is Google's Gemini AI, and the free source APIs which are available, which are built in with Google's Gemini 1.0 Pro version. We have used that, which is freely available. So we have generated certain images for 5 problem statements, what we consider as sensitive representations. Coming to the related works, we have come across some of the certain papers like content generation, how it is important. And we all know that, like in the current scenario, just every person can become a journalist by himself or herself, because since we all have a mobile phone with us, at the same time, social media plays a critical role. So we can easily pass on the information even to uneducated peoples. So this content generation as well as media plays a very important role. When they both go hand in hand, it can impact the society a lot and provide many valuable information. So what we understood is that the content generation, when collaborated with media like social media or any type, even if it might be in Hindu ad or even the railway stations, where we can deploy some screens and keep this content, so that people who are all coming, where it is a crowded place, we can easily pass on the informations which are considered as sensitive in the society, or it might have some cultural effect where people are not allowed to know, or where men are not allowed to know. Certain things like this can be easily passed on to the society. Coming back to it, we have successfully generated images by using some of the literature survey ideas, what papers, how they have implemented. Using that, we have just selected this Gemini AI tool, and we have used it for our implementations. So this is the proposed method. So we have used Google's Gemini AI, which integrates image generating model for giving high quality images. So the first thing is we have to generate prompt. Prompt or nothing, it is just an input what we given to the large language model in order to obtain the images or any content what we want to generate. So the prompt should be designed in such a way it should have the contextual relevance. So what output we are trying to get, the input should be in such a way it should be relevant to the output and it should be crafted. So this is the first step. We have to develop prompt in order to get the images. So this involves like a lot of trial and error. So we have to fine tune the prompt. So next one is API parameter optimization. So within the prompt itself, there are like certain features where we can go and optimize like the quality of the images, like resolution, aspect ratio, and what is the scale, whether data should be displayed or whatever it might be. It should be like continuous refinement and improvement for your image output. So this is our second step in generating the images. So next one is your image creation. So next one, once we give the prompt and again when we are self-tuning it, your Gemini, that is a large language model, will be giving you the output based on the input parameter what we have given. So the generated images are evaluated on the basis of it should be respectful representation of the sensitive issue. Then conceptual clarity and accuracy should be there. At the same time, aesthetic quality. So it should be that detailed composition and style, everything should be available. So we have used these evaluation criteria and we keep repeating the cycle until we get the desired image, what we think and what is very clear. So next thing is your post processing and refinement. Here we have to refine the output. We can go to the first phase to modify the output also. At the same time, we will have some quality control measures. All these are available in the form of parameters in the Gemini large language model. What we were using, we can just go and set the value. So it involves a lot of trial and error methods where we have to set the output manually in order to obtain a clear image in a conceptual way. So next one, we will be just selecting the images if it is in a conceptual way, and if it's good, we will be selecting the images. And final report is that a documentation is prepared relating to what is the prompt we gave, what are the parameters we have fine tuned, and the output of the images obtained. So we will be having the documentation behind it. And so in a country like India, there are also challenges involved in generating these images because copyright is an issue and ethical things. Since generative AI is a growing field, there are many privacy concerns as well as ethical issues which have to be followed. When your large language models is using some of the copyrighted images, then there will be a possible ethical issue associated with it. So this is the challenge what we faced in throughout this phase, that is implementing throughout this phase. So the input to the large language model should be clearly well defined, and we have to keep on repeating the steps right from prompt selection to image refinement before going to the final output and implementation phase. So these are all some of the output images we received. This was like downloaded from Google only, this menstrual cycle. So the conceptual image what was generated by the AI is this one, which came here. And the second problem statement is mental health awareness. This is the input image what we gave, and the output image generated by Gemini is on the right hand side. And this is the third societal cost we took. It is the domestic violence among kids. So this is the image we get, and this is the output image. Output image, that is right hand side gives the output image. So next one, this is the climatic change issue. So here there are like lot of text, and the conceptual image won't contain any text. The reason is when we design prompt in such a way, when we ask Gemini to design a conceptual image, what it gives is that it takes off all the text images, because the agenda here is to make the people understand only through the sight of vision. Even if they doesn't know English, Tamil, or any other languages also, it doesn't matter, because the image will be, by seeing the image, we will be able to understand like what exactly is happening. So this can be used as an advertisement banner in our in airports or malls or whatever public stations, so that even people, since India is a country with less literacy rate, we can use this particular technology to.
This is a gentle reminder that 9 minutes have been completed.
Okay, sir. So this is the third thing, that is abusive environment at workplace. I have just given some input image of office, and here we are getting it. And to conclude, the accuracy was a issue to be still, it has to be looked upon. And um, uh, I can tell that the conceptual images generated are not like 100% accurate. So we have to still work on it. And the future work is to try using our paid version of Gemini, since all the APIs we have used for this generative AI belongs to open source, that is freely available alone we have used. That's all, sir. I conclude my presentation. Thank you so much, sir.
Thank you for your presentation, ma'am. Are there any questions?
It's very interesting to understand how do we evaluate the quality of image in context of our prompt or the reference image given. Means how do we ensure that a conceptual understanding is embedded into a generated image? Can you throw any lights on this?
Sir, while the first phase, while we design our prompt to the language model, we use the terms called like, please generate a conceptual image, and we specify the image quality ratio, everything like it should be in this much pixels, whichever is available. So as far as we are using this free API, to some extent only this image quality will be there. So the thing is, we have just used it with all the open source API which is available. And I do agree that the image quality as well as the accuracy has to be improved. And we are just continuing our research, so that we will be using some paid versions, so that still our research could be progressed in a better way. And,
Yeah, you may probably focus more on the evaluation aspect of the generated image, because if you use paid also, Gemini will create some images, but in the same prompt you may have different images created, right, based on the context which has been captured by the Gemini at that point of time. But being a researcher, our objectives, one of the objectives should be how can we give confidence to the users that the image is clearly explaining the concept, that what we want, the purpose we meant for creating it, right? So please think on that direction and just try to add those dimensions in your future research.
okay, sir. Thank you, sir.
Thank you. Now we'll be moving on to the next presentation. I would now like to call upon Ma'am T.A. Alka to present her screen paper on the title Spotlight on Rural Entrepreneurship, a Bibliometric Journey. Do we have you here with us, ma'am?
Good evening, sir. Am I audible?
Yes, ma'am, you're visible, but your voice is not audible properly.
Sir, is it audible?
Actually, the sound is very low. Could you speak a little louder?
Sir, is it audible now?
Yes, ma'am.
Okay, thank you. Sir, is my screen is visible? Hello? Sir, is my
Yes,
screen is
ma'am. Your
visible?
screen is yes, ma'am. Your screen is visible.
Okay, thank you. So, good morning all. Myself, T. Alka. I'm a research scholar from Amrita School of Business, Coimbatore. I'm going to present a paper on Spotlight on Rural Entrepreneurship, a Bibliometric Journey. The paper is mainly discussing about the rural entrepreneurship thematic evolution, and also some collaborations that does happen in the entrepreneurial research, especially in rural context. So when we're looking into this introduction, we can say that rural entrepreneurship is creating contributions to the economic growth, that's promoting the sustainable livelihood and also changing the rural communities to a better way. And they are more focusing on local resources, and they are more focusing on the resource-based view, and they are helping to reduce the poverty and creating employment generation. So these are highlighting the contributions of rural entrepreneurs. But when we're looking into this urban entrepreneurship research and rural entrepreneurship research, most of the research are focusing on urban side. So there is a lack of research that is focused on rural entrepreneurship point of view. So this study is mainly addressing about how this evolution of rural entrepreneurship across the years, especially starting from 1970s. So the major challenges that we can say that rural entrepreneurs are facing about the technology access, mentorship, finance, market-based challenges. So these challenges can be addressed, and what we can identify what are the major critical success factors, as well as what are the themes evolved in this entrepreneurial research. This will be helpful for the sustainable research. So the major importance of this study is to address the research gap that is focused on less research is concentrated on rural entrepreneurship. Then also we are providing a thematic analysis and explaining this collaborative networks that will be helpful for the policymakers and also countries to focus on more on research. And the next thing is to provide the practical insights and the regional specific development we can identify. And also it will be helpful for these entrepreneurs to understand what is the action for concentration on research on this area. So this will be helpful for both academic and practical. So for this, we have framed two research questions. First one is on what are the themes evolved in rural entrepreneurship research, and second one is on countries collaboration. So the methodology followed for this study is Puffer SLR protocol. This is a review methodology which is highly used in systematic literature review as well as bibliometric analysis. These were developed by Politol 2021, and this methodology contains three stages: is assembling, arranging, and assessing. In assembling stage, there are two filtration steps that we are following. First one is on identification. Identification phase, we are defining the scope and also framing the research question and also selecting the quality of papers. Then in the acquisition stage, it's based on the database selection and the search keywords that we are following to filter the papers, and also that will be based on this Boolean operator. So here the keywords is rural entrepreneurship and rural entrepreneur with a keyword and almost 439 papers we found. And in the arranging stage, it's more about the filtration has happened, that is removal of irrelevant entries based on the context. And also we are ensuring the clarity based on the title, abstract, and keywords that is relevant to the study. And for these stages, we are following the assessing stage, that is mainly the analysis phase. So here, biblioshiny package is used for the analysis, and the reporting is conducted through tables, graphs, and keyword occurrence maps. So the final output is from 439 documents are analyzed in the results and discussions section. So this is just a glance of the whole methodology and SPA for SLR protocol that stages. So mainly we can say that the production of these papers are evolved from 1970s to that's current present time. That's almost 67 publications were recorded, and that will be highlighting this interest in the rural entrepreneurship research. But there are still lack of research that is focusing on rural entrepreneurship. So we can expect this growing trend reveals that there is more papers that will be, or more research that will be conducted in the future coming years. So thematic analysis, we are identifying major two like the future research aspects as well as already that's explored thematic area. So first one is on upper right quadrant, which is called as smarter themes in the figure. That's mainly focusing on what are the major central and relevant topics. Here we are framing and based on the keywords occurrences, we are understanding a theme that is rural agriculture entrepreneurship contributions to rural economic development, that is focusing on more on agriculture entrepreneurial view. And the second is on that is already existing theme, then there is no kind of any scope for future research that is need for rural entrepreneurship among this college students in developing countries. So there are a lot of research that is already happened. So this is the less future possible area. So we can expect more focus on the research, especially in agriculture entrepreneurship context based on the current trend. So these are the major motor themes as well as based on the relevance degree, the emerging or declining theme. So based on the countries collaboration, we can see that top contributing countries are this UK, that's 123 publications, and India is followed by India is 108, and United States is 103, and China is 183. So based on the collaborations, we can say that more collaborations happened on North American Asian collaboration, that is US China, and also there is an intra-European and transatlantic ties that is conducted between UK USA and UK Sweden, and the Spain Colombia that Europe and South America connections, another collaborations that we can see. And the Netherlands and Turkey, that is Middle East collaboration, is evolving. And Malaysia, Pakistan is showing this Asia with Asia cooperation. And China and Canada is showing this Asia North American collaboration. So these are collaborations we are mapping for to understand what is the current research collaborations that is happening in rural entrepreneurship research. So this is the country collaboration map we identified. And based on this thematic analysis, there are 5 themes that we are identifying that is based on this trend topics, that is rural entrepreneurship and economic development, agriculture and rural entrepreneurship, fostering innovation in rural areas, promoting sustainable development, building a sound entrepreneurial ecosystem, are all in the growth of developing countries. So there will be a future research to understand what are the major pathways for these areas that having future relevant scope according to this current research publication. So more research that we are required for the context specific as well as impact driven studies, especially during this kind of different sectors involving rural entrepreneurs. So major findings is mainly highlighting that there is a still research is very less explored this rural entrepreneurship area, as well as there is a future research scope here. And the core theme is mainly looking into this perspective of agriculture rural entrepreneurs, that they actually we are when we're looking into this SDGs and sustainable development, there is a still more focus is required on this rural economic development. So this rural agriculture entrepreneurs is playing crucial role. So the core theme is mainly looking into this agriculture context, and also there will be an importance of entrepreneurial education, especially during this graduate students, that is showing the academic entrepreneurship point of view. And the trend topic is mainly on how this are contributing to the economic development of a country, and how they are fostering agriculture, especially the sustainable innovation point of view, and also this entrepreneurial ecosystem, and how it will be evolving in the developing countries when we compare with the developed nations like UK, USA. Still we can say that there is a research is growing on India and China, that's more emerging and developing countries. So that will be reflecting the key research focus on rural entrepreneurship. So there will be more future research that will be happening in the coming years on, especially from the developing countries. So that's publication. We can say that there is growing number of publications also highlighting the more research focus in this area. So limitations, we know that this is a systematic literature of exploration. So there will be a lack of primary data that will be conducted in more in evidence-based or like first-hand information studies in the near future. So this is reflecting how this current research landscape on rural entrepreneurship. So we can extend the study by incorporating more databases, and other than this filtration step, there can be a possible other filtrations that we can do, and more another point of view study with limiting to some collaboration or some thematic analysis. So this is kind of a broader study. This is a preliminary research. Still, there is a lack of research that is that is examining the evolution of rural entrepreneurship. So this is the novelty of the study, and it's also opened the scope for future research. So this kind of secondary data or already published workspace study is we know that that's lack of primary data, first-hand information. So there will be future research that is going to happen based on the primary data. So
This
we
is
can
a gentle reminder that 9 minutes have been completed.
Okay, sir. So the primary data study can be like including the surveys or interviews, a case studies we can say. So what one of the major highlight that I found is there is a lack of case studies, which is highlighting the developing or that's rural specific or context based studies. So there will be a need for more case studies and longitudinal studies to track actually what is the evolution of rural entrepreneurship apart from this publication analysis. So there will be more research that we can say is focusing more on impact of rural entrepreneurship on specific sectors like health, education, and technology. So this about the paper, sir. So I'm just concluding my presentation. I hope that it's clear.
Thank you for your presentation, ma'am. Are there any questions?
Can you tell me some specific challenges or research gap you have come across for some regional areas or India as a country whole?
Yes, sir. Actually, when we're looking into the context-specific analysis, we can say that most of the research that is happening on developed countries' point of view. So, still, the rural is like we have to develop the rural areas and the entrepreneurship in this kind of underdeveloped areas, especially in developing countries. So, that is one of the context-based research gap that I found. And when we're looking into the sector-wise analysis, there is a still research that is more happening on this agriculture point of view. So what about these contributors in the healthcare sector, how they are contributing to the healthcare development, how they are contributing to the education? So that is still lacking. So that's why I just ask adding that there will be more future research that is more focused on this sector wise as well as the case studies. So we are very come across with very few case studies or nearly less than 5. So that is also from the perspective of Sub-Saharan Africa. That's not only covering the all global landscape. So there will be more case studies as well as sector wise analysis required, sir.
Okay.
Thank you, sir.
Thank you for your presentation, ma'am. Now,
Thank you.
moving on to the next presenter, I would now like to call again Sir Rahul Daigude to present his paper titled Artificial Intelligence for Enhanced Logistic Tracking in Hospitals. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we will be moving forward. I would now like to call again Ma'am Akansha Katore to present her paper on the title Empowering Farmers Through Technology, a Java-based mobile marketplace for agriculture trade. Do we have you here with us, ma'am? Do we have anyone else with the team with us? Since there's no response, we'll be moving forward with the next presenter. I would now like to call again Sir Shankar Lingam to present his paper on the title ICT Policy and E-Governance, Navigating Intergovernmental Issues in the Digital Era. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward. And with that, we come to the conclusion of this session. I sincerely thank our authors for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank the session chair, Dr. Amit Thakur, for chairing this session. I would now like to request Sir to share his thoughts and feedback about the presentations for the session.
So first of all, I'd like to thank all the presenters for the nice presentation in the conference. I'm happy to see the different areas from medical science to AI to rural entrepreneurship. So a lot of diversity has been observed in the presentation. So I must hope that all the participants have learned a lot of directions for the research for the betterment of society and a nation as a whole. Again, thanks for the organizers for inviting me for the session, chairing the session. I really enjoyed the session, and also I have added a lot of knowledge to my knowledge database. Thank you once again.
Thank you, sir. Here's a token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. Just before we end the session, I would kindly request you all to switch on the cameras for a quick snapshot of the virtual conference. Thank you everyone. Stay safe, take care.